So the QR code will take you to our community, and all of these slides are also available inside the community as a PDF file. So if you want to check some of the technical information or details, you can refer to the slides later on. And then some of my other presentations, as well as podcasts and other things, are also in the same community as resources. Here are the companies grouped by the technology that they're working on that are making quantum hardware. And some of these are very advanced, and some of them are a long ways away. My pick for the leaders would be PsiQuantum and Riverlane, because they have very good manufacturing at PsiQuantum, and they have very good gates at Riverlane. A lot of people are just paying attention to, IBM, they're paying attention to D-Wave, they're paying attention to Rigetti, but like Alice and Bob has a much more advanced system that isn't getting much attention. With this many companies working on it, and there's more joining and growing, there's more likely going to be a predictable hardware increase. Now, as the algorithms improve, the hardware requirements go down, and then as the manufacturing improves, the hardware performance goes up. This was a report by McKinney, and they're saying that basically 2027 is the start of being able to possibly break RSA 2048. Elliptical curves used by blockchain are about 5 times weaker than RSA based off of the scaling for handling the additional bits. What the algorithms mean for quantum computing breaking elliptical curves and blockchain is that they switched from a single computer that we can't build to a large number of small computers that we can build. And that network mode runs 45 times faster. So there's more of a threat from the algorithms than there is from the hardware, and this is much more attainable. This is just people who can do math at their house. This doesn't require access to liquid helium and advanced physicists. This is just programming and mathematics in a different way. The scaling for PsiQuantum's active volume architecture, if you triple the qubits, you 7x the speed. So they were talking about how to break Bitcoin in 10 minutes using 6,000 nodes. Well, if you cut the number of qubits down to 1/9, then you're cutting the speed by 1/49. And so you're talking basically 8 hours on 1,000,000 qubits. So, a lot of people say that blockchain and Bitcoin, they're going to be fine because the banks are going to get hacked first. All these the whole world is going to have problems, and just Bitcoin and Web3 are going to survive as the new dawn to a new revolution. And for some reason, everybody else is upgrading, but Web3 is not. I was at the Bitcoin conference in Vegas. There was 6 presentations on migration to quantum safety. There was multiple panels, and I'm part of that community as well. So the issue is that Bitcoin is now talking about this, but Web3 is not. So we should at least catch up to Bitcoin and plan our migration strategy. Bitcoin has a viable migration strategy. One of the questions is, what do you do with Satoshi's coins? The problem here is that the information on the ledger is all that is required to wreak havoc throughout the entire ecosystem. Quantum computers can turn the public key into the private key when they get big enough or the algorithms get small enough. The disadvantage here is that it's very easy for Bitcoin to add a new address type. It is extremely hard for Web3 to add new address types when you're dealing with smart contracts and Web3. So just the extended use case means massive extra complexity in terms of migration. Ethereum Foundation looked at converting from 160-bit addresses to 256-bit addresses, and they basically gave up and said it is not possible. And that was after they worked on it for about 2 years. So the quantum attacker can become anybody. Now, in terms of like what happens when Q-Day occurs, Q-Day is probably going to be accepted as the day that Satoshi's coins move. And then people will start to sell their assets. And if they're converting from ETH to USDT and then trying to withdraw it to their bank, how much money will actually exit the system? And so you're going to run into a problem where people will sell at basically any price if we don't prepare. This is basically the damage that will be caused if we don't prepare. The more that we prepare, the less people will try to sell, right? The less damage will be done to the underlying security. So one of the reasons I say that people will agree on Q-Day is that we don't actually know when it will occur. We may not know when it occurred until several years after the fact. There's a large number of Bitcoin wallets that have over 1,000 Bitcoin. There's over 2,000 of them. Every month, one of them sells like $30 million worth of Bitcoin or $100 million worth of Bitcoin. Every month, like clockwork. It's really weird. Is that a quantum attacker? We can't tell. So now, migration. These are the various topics that have to be covered in order to actually handle migration. You have to migrate the consensus model, the wallets, and then the data on the ledger. And the first one, consensus, is actually the easiest to do. You tell whoever's validating your transactions, you have to use this new cryptography, sign a transaction, move your proof of stake to the new system. It's not that hard to do, and you know they're going to do it because they have so much money at stake. Users are a much different problem. They generally don't follow instructions very well. And in the case of EIP 7702 and 4337, it's no longer having the public key on the blockchain itself, but now it's this third-party authentication system. It can be MPC, it can be multisig, it can be local devices, it can be some code that's running on some server, and that authenticates the transaction. And that makes it harder to force upgrades because now you have infrastructure that's also has to do a different upgrade in parallel to the main upgrade. But it's also safer because they don't have the public key sitting on the ledger. They can't just get the public key, get the private key, and then drain the funds. The ledger itself, I'm going to have to cover in more depth. So the methodology of migrating the consensus. There's different pieces that have to be changed. The first one is the block signatures. Whoever's signing that block, they have to now do it with a post-quantum signature. If they sign a block and they don't have a post-quantum signature, well, then the attacker has that key and now they can sign blocks as if they were that validator. The second thing, the validator contract. This is very specific to Ethereum, where there's a lot of delegation that occurs. So the delegation methods are also part of the surface area of attack. The way in which the contracts manage between the validators and the actual staking, the queues that occur, all of that is now part of the surface area of that can be attacked. And all of that has to do a more complicated migration because now there's a lot of technology and infrastructure in place around that contract system. The proof of stake, and knowing that basically there's assets that are being staked, it's possible for the attacker to simply drain the staked assets and say, oh, you're not validating anymore. As part of the consensus, it's also possible for the attacker to slash honest validators in concert, because they will have multiple keys. They would be able to perform actual slash attacks against something that maybe has a contract or isn't using the same architecture, or they could slash someone that they dislike for some reason. They can cause unlimited havoc within the Web3 ecosystem. And then the network protocols, this is more specific to like Polkadot and XX network. The network protocols for Cosmos also have the elliptic curves inside the network messages. That's a bad thing. That makes it very, very hard to migrate. The transactions, they need to be post-quantum cryptography, and they need to be checked by whoever's validating the block and validating the transactions, and that is a scaling problem. And I'll cover that later on. So, when the wallets are signing the transaction, they're using their private key to do an elliptical curve signature, and then they're submitting their public key along with the signature to prove that they are the correct and responsible party for managing those assets. It's fairly simple to change the cryptography, but every user will have to sign a transaction that goes from the old cryptography to the new cryptography and the new wallet address. And the new cryptography will have a different method of signing it. So EC recover, ethers.js, all that stuff has to also be replaced. Web3.js, hard hat, all has to be replaced. So this is very simple thing in terms of doing the transaction verification for Bitcoin is actually really, really hard for Web3, no matter which protocol you're referring to. The EIP 7702 was my big hope to actually go to quantum safety because I was really, really hoping that they would force a quantum safe method, and then the validator of that transaction, whoever's hosting that account, would then accept that post-quantum methodology, and they would not have to publish a public key. Instead, what happened is that you now have this basically unmanageable system where any validation provider or signing provider can use whatever architecture they choose, and you've now pushed a centralized problem to a decentralized, distributed problem where phones are using fingerprints or the 6-digit recovery phrase as a method of proving and validating transactions. It's a problem because now we can't necessarily upgrade it in the same way. And the surface area is, again, increasing. So even if we do everything right in one way, we might fail the other two steps and still lose hundreds of millions of dollars in TVL. This is where it gets hard. So every time you have a smart contract that has an admin, that admin has some level of permission over that contract. Anything the admin can do, the attacker can do. All of the admins need to migrate from the old cryptography to the new cryptography, but it may not be able to hold the new cryptography, and they may not have added the management where they're able to transfer owner from signature 1 to signature 2. The smart contract may not have the correct logic in validating the new signature, or the error checking may error when it should have succeeded for a post-quantum system. And that's just the admin migration function. So each one of these smart contracts has a large amount of surface area based off of the ecosystem usage. If they're able to upgrade that smart contract, well, the attacker would be able to upgrade that smart contract and replace a known good library with an attack library. Then, post-quantum signature, users that migrated properly could call the now corrupted smart contract and lose all of their funds anyway. The contagion in a mixed environment is extremely bad and extremely dangerous. So there's a lot to do here. Bridges are going to be, of course, hacked like usual because they have large balances. But now it's not just, let's say that Ethereum, upgraded everything, but then they're bridged over to Binance Smart Chain, and whoever manages Binance Smart Chain end of that bridge didn't upgrade everything. Well, now the Binance Smart Chain can be attacked and drain funds that were shared between Binance Smart Chain and Ethereum. So every single peer also needs to upgrade, because otherwise the manager of that bridge or the funds on either side could also be drained. The attack surface is very, very high in Web3. Algorand is like, yay, we're doing post-quantum because we have a backup of the chain history having a Falcon signature once every 5 to 10 minutes. And I do not know of any attack that prevents. So some people have actually done this last item and none of the others, and they're advertising themselves as being post-quantum. No, they haven't done any of the other work. Algorand also has an additional problem because they have data owned by a wallet, managed by a manager, and most of the time there is no ability to actually edit who owns, manages, or does bookkeeping on the data. And there's also staking involved in having data on chain. And sometimes these wallets cannot be replaced. So I expect that they will have to make their immutable ledger simply editable in order to change all of the addresses. I don't expect them to actually complete this task. Any questions so far on this? Because now it gets hard. Oh, Mike.
Just a quick question because I arrived a bit late. This seems really serious. How close do you think this is?
The attackers say that they'll be ready to attack in 2027.
Which are the attackers? Who are they?
That was the first slide. I think that PsiQuantum and Riverlane are the closest, and they both said they're going to be ready by 2027. There are multiple attack avenues. There is a large number of algorithms. There's Shores, optimistic Shores, Regevs, and a fourth one I don't discuss. The resource requirements go down year after year. The typical rate is a 10 to 100x performance improvement every 1 to 2 years. It is, even with no improvements in the algorithms, that we're still talking 2027 and 2028, based off of the active volume architecture, network mode, and the ability to simply scale up through mass production, which has been going on for the last 13 months.
Okay, thank you.
Soon. Another question?
Sort of a follow-up to that. How expensive would that attack be to perform?
A couple $100 on equipment that costs a few $100 million. There's also the possibility of doing emulators instead of quantum hardware. But the emulators, there would have to be algorithm and emulator improvement performance that would be significant before that would be possible, and then you just would be able to rent mainframe time for a few $1,000s to do it. Unfortunately, it's really cheap. I've heard people say, no, it'll be too expensive to run the machine. Those quantum, you have to buy helium-3 and helium-4, and the radioactive isotopes only come from nuclear reactors or volcanoes. Not all of them. You can just, PsiQuantum runs on liquid hydrogen or liquid helium. It scale at giant, massive steel fridges. So it's cheap for them. Okay. So now the harder stuff. The scaling, the rollups, and the Schnorr signatures. Now, one of the things that the Lightning Network, the Ethereum network, and Solana have all done is they've all used the same equation for aggregating signatures, and most of the rollups use the same equation. The Schnorr signature is ED25519. This is an elliptic curve, and you can take an unlimited number of transactions or signatures and compress and merge them into one single signature that is the same size. Check that one signature, and you know that every single signature is valid. If it fails, you can do them in batches. There's no quantum safe replacement for that. There's nothing in post-quantum cryptography that does anything similar to that. Inside quantum cryptography that uses quantum computers, yes, there is something similar to that, but there's nothing that would work on silicon that is also protected against quantum computers. So layer 2 has lost their cryptography. They lost their scaling. ZK snarks are directly attackable because there's an elliptic curve inside the circuit that proves the circuit and proves the validity. And then multi-sig MPC and like Schnorr's secret sharing, these all are attackable by a different algorithm known as the abelian hidden subgroup problem. It also has a polynomial time speedup. It is also just as vulnerable. So use of multi-sig has to become ephemeral, and it should be done on blockchain. Via smart contracts. There isn't a way for banks to continue to do multi-party computation and secret sharing amongst themselves without having some kind of like smart contract that does the logic. The mathematics are expiring for security. Fully homomorphic encryption, which is available on Ethereum today, is the possibility of having a privacy layer. It's basically like you have a spreadsheet that you can do math on without seeing the numbers that you're doing the math on. And there are variations of fully homomorphic encryption that are post-quantum. ZK Starks are also post-quantum, but nobody uses them exclusively, not even StarkNet. This is a problem that every blockchain will experience to some degree. For Bitcoin, not every address has a known public key. The question of what to do with the assets that don't migrate to post-quantum. Right now, there's 6.2 million BTC sitting exposed with known public keys. Web3 has 100% of its addresses basically known with known public keys. And then the new EIPs are changing that, and they're making it basically a delegated problem. What do you do to people who don't migrate? And if you don't burn the addresses, you're leaving all kinds of problems in the chain, but that would destroy a large amount of value. However, if you don't burn it, you simply give that large amount of value to the attacker. One of the reasons why we cannot migrate easily is that we have to migrate before the attacks begin. If we allow the risk to come to fruition, and there is now the possibility of a quantum attacker, the quantum attacker can migrate the funds to their quantum safe wallet and out of the original owner. So you've simply facilitated theft by delaying migration. If they don't migrate, you probably have to burn them. And that means most of Web3. Even if we migrate starting today, which the technology doesn't exist for the most part, that's still what we would need to do. Now, the Bitcoin protocol will still function until the machines get under 1 hour solve time. Web3 won't even have the protocol. So the basic opportunity here is replace all the math and replace the leaders. If you wanted to become the new Uniswap, now you can. By changing to a blank slate, there will be a new #1 for each category. Maybe Uniswap will migrate early and still keep their #1 throne position, but the real opportunity here is that there's a bit of a shakeup, Bitcoin will have forks. You might benefit on 6 forks and sell some of those Bitcoin and keep the rest. But it's all going to change. It's one of the things that I'm looking at doing is providing quantum safe technologies to do quantum computing, because that makes sense. And one of the partner businesses is going to basically run a compute network for running AI on quantum computing, which is really good. Cryptography requirements are harsh. You have to replace all the public-private stuff. You have to replace, well, some of the symmetric keys are also broken. You have to use lattices and codes. I highly recommend NIST post-quantum cryptography, not the thing that they made last week in their garage. And also, Falcon has not been standardized, so if you use Falcon today, you have to throw it away for whatever the next version of Falcon is. Quantum-resistant chains, quantum EVM is, I'm the CEO, unfortunately. Cell-frame technology that has scaling and built-in. KelVPN is built on Cell-frame, but this is a post-quantum VPN, which is rare. QRL is the oldest, and they're using hash-based signatures. They're going to migrate to a smart contract architecture either late this year or middle of next year. They don't have a roadmap timeline. Mochimo is a small proof-of-work system. They're microcap, but they're actually post-quantum. So I give them applause. And QR code to join the community and get the presentation.
Thank you so much, Ian. Everybody give a hand to Ian.